Okay, so let's take our quick look at the calendar. Today is lesson number 3. We are covering something called linear models, lots more word problems that we'll see today. A couple of quick announcements before we jump in. Number 1 is up here on the board. The other day I told you the format of the titles of my videos on YouTube, and I've decided to change from what I said the other day, which is a change from what's in the syllabus. So this is what the videos are called. So if you feel like searching for a video by title, it is something like 096 Fall 2015 Lesson 2. Today will be called Lesson 3. The playlist still exists in the same place, and you can still get there through Moodle. You can still bookmark it and not worry about the titles at all. But if you are searching for a specific title, I have made a change from what I told you last class. Any questions on that? Okay. Next announcement, I have one last My Math Lab handout that I've put on your tables. This will be the last handout I give you for a while, so grab one of these. Last class I gave you a My Math Lab handout that will hopefully save you from some frustration. Now that we've gotten past that and you guys are experts at My Math Lab, this is how you become a super expert with lots of tips and tricks and become really efficient and good at using My Math Lab, okay? So check this out later on, save yourself some time. Okay, next. At the start of every class, I'm going to get here a little bit early, and I'm going to check the homework of the people who get here a little bit early. So all of the homework that I look for is in My Math Lab. I don't grade anything that's in the packet. I'm only grading stuff that you do on My Math Lab. You answer all the problems on My Math Lab, but you write your work down in a notebook or on scrap paper or something, and you show it to me, and then I give you credit for doing all the work, okay? So I checked some people this morning, but I rarely have time to check everybody, so I'll try to check folks during class if I'm able to. But I just want to be clear that doing the homework on My Math Lab is not enough. You also have to show me the work to support what you did on the computer, all right? Okay, last thing is about the questions that folks answered about the syllabus. On the very first night, I assigned 4 questions about the syllabus. And so if you hadn't already turned in those questions on the syllabus, throw them into the yellow folders right now. But for those people who had, one of the questions I asked you was, what questions do you have for me at this point in the course? And so I wrote down the questions that people had, and I just want to respond to them right here. So somebody wanted to know if there were any practice tests or quizzes for the semester, and the answer is yes. On the first day of the semester, I handed out kind of large packet that says at the top, practice problems for Math 096. I handed this out on the first day. I have more if you need, but everybody should have picked one of these up on the first day. And that is the whole semester's worth of practice problems. And we'll talk a little bit more about that document as we head into quest number 1, which is coming up not too far from now. But those are all the practice tests and quiz problems. Okay, so that separate packet. Next one, question about is there any lecture during the course, or is it all group work? So I think I've mentioned this now since the first day of class, but the idea for me, I'm hoping to do the lecture part of the course pretty quickly, 10 to 15 minutes maybe, and then the rest of the class will be group work. So hopefully that works for everybody. Is the homework graded, or is completing it enough for full credit? Great question. So when I walk around checking your work, I'm going to assume that you did everything that you were supposed to do. I'm really just looking for kind of broad brush strokes. Is the algebra justifying the final answer here? My math lab is going to be a whole lot pickier than I am in terms of getting the answer right. So those of you who have already started doing the homework, you can see you either get it right or wrong. And hopefully you just keep doing it again and again until you get it right and you get 100 on it. But just doing the homework isn't going to be enough because my math lab counts it and grades it as either right or wrong. And then finally, somebody asked me if I have any sports or hobbies that I like to do. I used to play a lot of volleyball when I was younger. I'm pretty darn good at ping pong, but right now I'm a runner. And in terms of hobbies, I like to read, I like to watch movies, and I really like playing with the Rubik's Cube. You guys remember that puzzle? Yeah. So those are my sports and hobbies. All right, so thank you for the questions. And with that behind us, I think we can jump in right here on page 16. Okay, so we'll start with the daily summary up here at the top. Can we go to Ryan for the daily summary? Ryan? Can you read the daily summary, please?
In this lesson, we saw word problems that involve linear equations that find. We also learned how to identify variables as well as how to create equations for one variable.
Okay, thank you. Carmia, 0. Okay, so occasionally you will type something into MyMathLab, some complicated expression. It'll say it's wrong. It'll show you the right answer, and they look exactly the same to you. Don't go crazy. Don't get frustrated. Just send me a quick email. If you can't immediately identify what the issue is, just send me a quick email. I think there's even a button right there on the homework problem that says send your instructor an email. And I'll take a look at it, and if I think you got it right, I can give you full credit. If I see the error, then I can tell you, and then you'll avoid that error in the future, right? So don't go crazy with any of these problems on MyMathLab. Okay, number 1, I will go to Kelsey. Okay, so $15 per hour, that's going to be our salary, and we're going to begin by filling in the table of values below. The first column you can see I'm calling X is the number of hours that we work. Second column we're calling W for wages earned in dollars. So if you work 0 hours, what are your wages? 0. Sad but true. If you work 4 hours, what are your wages? 4 times 15, which is 60, right? So $60 there. And let's fill in the other 2. 6 hours gives $90, and 10 hours is $150. We're going to plot the points in the table. I'm not going to write them all out here, but normally it's an ordered pair called XY, but here it's XW, right? No big deal calling it W instead of Y. And so for the second row of our table, what's the ordered pair? Second row? 4, 60, right? So you've got 4 points right there. Go ahead and plot the 4 points on your graph. Yeah, and if it makes a line, then we should connect the dots, and we'll talk about why it makes a line. Okay, so we've got our 4 dots. And let's talk about why it makes a straight line. What was our salary? $15 per hour, and it's fixed. It's not $15 for the first hour and then $20 for the second hour, right? Because that wouldn't be a straight line. But the fact that our salary is fixed, it is a constant rate of change, is why we have a straight line here. And essentially that's the defining characteristic of a straight line. Close up. What's that? The first one was straighter. All right, so make me do this again now. All right, here we go. Come on. Okay, so let's answer part D. Oh, sorry, we're skipping something. Part C. Where are we now? We'll go to Victoria for C. Yes, do you mind? Okay, let's pause right there. So, brand new definition, brand new phrase. If you see the phrase in terms of, it is a precisely defined mathematical phrase, and we're defining it right here. W in terms of X means the equation is going to be in the form W equals some stuff with X's in it. Those dots are my way of saying I don't really know what's going on the right-hand side, but there's lots of crazy things with lots of X's floating around. But the key feature here is that W is by itself on one side of the equation, and then lots of X's on the other side of the equation. So as soon as you see W in terms of, you translate that to W equals. W in terms of means W equals, all right? So essentially in terms of means there's going to be an equal sign. Okay, so what's our equation here? What do we do to the number of hours worked to find the wages? Multiply by 15. So what's our formula here? 15x divide. X was the number of hours. Multiply that by 15, you get the wages. And that right there is an equation for W in terms of X. W equals some stuff with X's. And the thing on the right-hand side could be more complicated. Minus 5x squared divided by 2x. I don't know. Doesn't matter what's going on the right-hand side with all those x's. The important thing is W equals is by itself. Okay. Part D we answered already, but we'll read it again. For each increase of 1 hour, how much more does the individual earn? That's $15. For each additional hour we work, we earn $15 more. And does that hourly rate change or is it constant? And Jasper said before it's constant. It is constantly $15 for each additional hour. And so in the next line here, it says this is an example of a constant rate of change. Your salary is changing by $15 per hour, and it is always that same 15. And that makes this a linear model as opposed to something else. And so here's our quick detour. That right there is the graph of y equals x squared. Anybody remember the fancy name for that graph? Parabola. Great. We will talk about parabolas later this semester. And this is not a straight line, and the rate of change is not constant. So what does that mean? For example, if you start at the point 0, 0, and then you move over to the point 1, 1, which I think is maybe right around there, you have moved 1 to the right and 1 up. Yes? From 0, 0 to 1, 1. But the next point I want to highlight is this point over here. It's 2, 4. Again, we move 1 to the right, but now how much do we move up? To go from 1, 1 to 2, 4, how much do we move up? We moved up 3 because we were at the y-coordinate of 1 and we got up to the y-coordinate of 4. So we had to go up 3. And the next point I want to focus on is at 3, 9. That's another step to the right, going from 2 to 3, but how much up do we go? We go 5 up. It is not the same 1 to the right, up 1, 1 to the right, up 1. It's not 1 to the right, up $15, 1 hour to the right, up $15. It's something that's changing. Right? And so for linear things, that rate of change is constant. We're going to have a word for that rate of change in a few classes. We'll call it slope. Many of you have already seen that word slope and know a bunch about it. It's okay if you don't know anything about it. But anyway, that's what makes this thing linear. Okay, more vocabulary here in E. Can we go to Andy? Okay, brand new vocabulary, dependent variable and independent variable. In this case, W is the dependent variable. I've got a silly mnemonic device. We'll see if it helps. Wyatt, if it helps, can you read this next part? Okay, so that 7.5x is a typo, my fault. W equals 15x was our equation here. And so this little mnemonic device says that to tell which of those letters is the dependent variable, your choices are W and X. You just have to find which one is by itself, just like Johnny Depp may be by himself in on an island in Pirates of the Caribbean. And so the Depp there is supposed to remind us of the word dependent. Dependent, Johnny dependent, I don't know. So W equals 15x. Which one is like Johnny Depp by himself on an island? What letter? W, and therefore W is the what variable? Is the dependent or the dependent variable. Okay, so let's move on to number 2 here. It says there are 2 equations, R equals T over 121 and T equals 121R. These equations are equivalent to each other. They're just written differently. Write down the one that expresses T in terms of R. T in terms of R. Yeah, as soon as you see T in terms of, you know T equals, right? That's just straight memorized. So the answer here is t equals 121r. And now we're going to fill in the blanks. It says since, now we're going to pick a letter, either T or R, is by itself. Which letter is by itself? T. And we're imagining that letter by itself on an island, just like Johnny Depp. So that same letter again, T, is the which variable? Dependent. And then by process of elimination, the other variable must be the independent one. So R is the independent variable. Okay, so we just had three pieces of vocabulary thrown at us. We had in terms of, we had dependent variable and independent variable. It's just memorized. It gets easy with practice, but the fact is, if you're just guessing, you're going to get it wrong half the time because there's two choices. Every one of these kinds of things has two choices. Okay, number 3, brand new problem. Let's go to Marissa. Okay, I'm guessing that some of us, when faced with that equation, desperately want to solve that equation for which letter, X or Y? Yeah, right? You guys have spent time in previous math classes solving equations that look just like that for the letter Y. Yeah? Okay, so we'll talk soon enough about y equals mx plus b, but we don't need it for this. In fact, if you just want to graph that line, solving for y is an unnecessary and complicated step. So what we're going to do is pick our favorite number for x. Now, my favorite number for x is 0 because that makes a term disappear. So we're going to pick our favorite number for x, which is 0. You can see that's filled in the first row. And we're going to rewrite this equation right here, but we're going to change the x into a 0. So 3 times 0 plus 2y equals 12. Where did the 0 come from? You can pick any number you want. We're just going to plot 2 points, right? That's all you need for a straight line. And one of the points we're going to plot will be when x equals 0. So 3 times 0 is 0, so we don't need to write that part. So this becomes 2y equals 12, which means y equals 6. Yeah? Great. Okay, that was so much fun. Let's try changing the y to 0. So brand new thought now. So again, going back to that green equation, I'm going to rewrite it. But this time I'm changing the y to a 0. So 3x plus 2 times 0 equals 12. Two times 0 is 0, so I won't write that part. I get 3x equals 12. And x is 4. All right, so we've got an x is 4 and a y is 6, and we're about to plot some points. Really common mistake is to plot the point 4 comma 6. 4 comma 6 has nothing to do with this problem. But it's quite tempting because I have an x and I have a y, and I'm asking you to plot a point. And the reason it's wrong is that the only way we got y equals 6 was by letting x equal what number? 0. That's the very first thing we did here was let x equal 0. So if we fill in the table, maybe we'll see what's going on. When x is 0, y is 6, and that leads to what ordered pair? 0, 6. Great. And the only reason x equals 4 came around was because we let y equal 0. And so that means x is 4 and y is 0, and the ordered pair is 4, 0. And those are the 2 points that we're going to plot, not the point 4 comma 6. 4 and the 6 have nothing to do with each other. So we plot those 2 points, 0, 6, 4, 0. And then we connect the dots. You guys gave me such a hard time about my line before. Take that. And I think that's the easiest way to graph equations of that form. No solving for y, no thinking about mx plus b, which we don't even have at this point anyway. You just find the 2 points where the line crosses the axes. And those 2 points have names. This point 06, what is it called? That's the y-intercept. And I guess that means the point 40 is then the x-intercept. Yeah. It used to be a 6-foot smartboard, now it's 8. Okay, so this is called the intercept method of graphing. I think it's quite useful. Any questions on that? All right, so demo is completed, answer key is there, but we just wrote all the answers. On the next page is where we start with the activities. Today, you're going to be spending some time writing sentences in English where you interpret problems in context. I'm going to be very picky, so please don't hear my suggestions as being like criticism. This is just me being picky, and we're going to learn how to write things very precisely in these activities. All right, raise a flag if I can help. Okay, so let's talk about these sentences. Like I said, I'm going to be very, very particular when it comes to grading your sentences on tests and quizzes. So let's make sure that you know exactly what I am looking for. So first, the y-intercept here is not just 800, although I guess you could say that, but I really want to make sure you understand that there's 2 numbers. Every point has 2 numbers associated. So if your sentence just has the number 800, but it doesn't either say 0 or mention what that 0 means, you're missing something important. It's got 2 pieces of info. Same thing down here for the x-intercept, it's 40. So what I always like to do is put units on the problem. So that's 0 what? Minutes, and that's 800 feet. And it's the same thing down here, 4 minutes and 0 feet. So then you start to make your first pass, your first attempt at the sentence. After 0 minutes, the balloon is 800 feet. Okay, that's getting there. It's kind of awkward at the moment, but it's a first attempt anyway. So that 800 feet, maybe you could say 800 feet high, or it has an altitude of 800 feet, or it's 800 feet off the ground. So now it's starting to sound a little bit better. But really, it's the time piece that I'm looking for, because it's quite easy to write something that just isn't true. So if you say that 0 minutes means initially, right? Initially, the balloon is 800 feet, or at the start, the balloon is 800 feet. Is it clear? Like, what does initially mean? When is initially? Yeah, but when did that happen? Is that what it says? There's something in this problem that tells you what precipitated the balloon starting to come down to the ground. We started releasing air. If you don't get that in your sentence, then you haven't described exactly what's going on, right? You say 0 minutes in, that's meaningless without a reference point. Our reference point, our starting point, is the moment we started releasing air from this balloon. So that's what I'm looking for. At the moment she started releasing air from the balloon is 800 feet high. Or when she started releasing air from the balloon. But she started releasing air from the balloon is an important part of this problem. What I really don't want to see is before she started releasing air from the balloon, because before is a very big word. And if I say before right now, I'm talking about all of eternity for the universe, yes? The word before means before. And so it's not before she started releasing air. I have no idea what was happening with this balloon before she started releasing air. All I know is at the moment she started releasing the air, we were right there at 800. So I'm gonna just skip to my answer key so I don't have to rewrite my sentence, but here's my answer for part C. At the moment the person begins releasing air from the balloon, the altitude of the balloon is 800 feet. If you prefer, instead of at the moment, you can change that to the word when the person begins releasing air, okay? For the other sentence, that was 4 minutes and 0 feet. So you could say 4 minutes, don't just say after 4 minutes, but say 4 minutes after what happened? We started releasing the air. And 4 minutes after a reference point. You could say the balloon was 0 feet off the ground, but that's clunky. That's a very like mathematical thing to say, and we're looking for a plain English thing to say. So if the balloon's altitude is 0 feet, where is it? It's on the ground. I'd really love to see on the ground as opposed to seeing 0 feet. I don't think I'll take points off if you say 0 feet off the ground, but it's awkward. And we're looking for a plain English sentence, not a mathematical sentence. I want it to be precise and I want it to be correct, but I also would love it to be plain English on the ground. 4 minutes after the person begins releasing air, the balloon is on the ground. Okay? All right, so take your time with these sentences. Like I said, this is constructive criticism we're offering here, and it's my way of trying to make clear exactly how precise I want you guys to be with those sentences. Okay, so pick up wherever you were, and I will keep walking around.